Beer is an alcoholic beverage produced by fermentation. The process mainly involves malting, milling, mashing, and other additional product-enhancing steps. First of all, the grains are allowed to germinate under controlled moisture content, air and water temperature, and air rests. Essential enzymes, such as alpha amylases and beta amylases, convert starch into simple sugars for fermentation, whereas beta-glucanases convert insoluble proteins and complex sugars into soluble amino acids and glucose. To avoid different rates of germination and grain clumping, most industries rotate grains periodically. At the end, the grains are dried by convection heat treatment to prevent further germination. Milling is the part where malt is broken into smaller sizes. It allows the mashing liquor to enter the center of the barley and enables better fermentation. However, the husk should still be intact while modifying grains into particles. Malt grist is then classified through sieve analysis. Milled malt would be mixed with 2-3 volumes of water per volume of grist using a mash tun at a temperature range of 62 to 67 degrees Celsius, producing an aqueous extract called wort which supports yeast growth. It is 10% sugar with amino acids, salts, vitamins, carbohydrates, and some proteins. At this point, starch is completely converted into sugar. Afterwards, the wort is separated by the mash tun with precisely machined slots. The milled malt is then transferred to a separation vessel. After separation, the wort is boiled in a vessel called copper. Enzyme activities are now arrested. Added hops are grouped into 3 categories: aroma, alpha, and dual-purpose hops. The female flowers produce glands that contain humulons extracted during wort boiling. The isomerized isoalpha acids contribute to beer bitterness. Saccharomyces cerevisiae is the preferable yeast. It converts simple sugars in wort to alcohol and CO2 through alcoholic fermentation. Temperature of the wort must be no more than 5 degrees colder than yeast to prevent cold shock, which causes prolonged lag phase and an off flavor of undesirable fusel alcohol. Esterification of ethanol creates a fruity flavor, but at high concentrations will have solvent-like taste. After boiling for 60 to 90 minutes, the wort is placed in a plate heat exchanger where worts are cooled and oxygen is added in. After fermentation, sedimentation removes yeast. The solution is transferred into a maturation vessel for optional secondary fermentation. Undesirable compounds are removed by Krausen and continued activity from yeast residuals. Long maturation slowly precipitates protein-tannin complexes. Maturation can be sped up by adding additional tannin, protein or tannin adsorbents, or enzymes that degrade proteins. Lastly, the beer is packaged into desirable bottles.